And welcome to Ladyada.
Hey everybody, and welcome to my desk. It's me, Ladyada. With me, Mr. Ladyada on camera control behind the scenes.
Hello.
And we're going to check in on what I've done at my desk this week. It's a long weekend, which means I can do even more. But let's see what I've gotten to so far, what trouble I've been brewing.
Yeah. What is on your desk this week?
Okay, so first up, as you can see on my screen, I am working on the Easy Link revision using the ESP32. That's one of the prototypes I put together. I think I gave Mr. Lady a time lapse that he will post later about that. And basically replacing the CSR chipset module, which we couldn't get anymore, and it was just kind of like a big gross mess, with an ESP32, which has classic Bluetooth. You know, TAC, who does a lot of Bluetooth work for us, figure out how to basically get SPP, which is the serial protocol in classic Bluetooth, to work on the ESP32 with flow control and baud rate changes. And that's really important because a lot of Bluetooth SPP examples they don't use flow control. It's RxTX only. There's no RTS, DTR, CTS, whatever. And secondly, they often don't let you dynamically change the baud rate. Like whatever the baud rate is when you either fixed to 9600 or they're fixed to 57600 or whatever. But what's really cool is that this module has baud rate changes and the flow control. So let's go to the overhead real fast now. I'll show it off in situ. So this is the module. So I'll unplug this, and this is the assembled version. So I've got here the ESP32 Pico, and I've got, the nice thing is, of course, it's ESP32, and we're programming it in Arduino. So it's like, I'm not programming it in the CSR IDE, which is kind of like a total nightmare. So there's a NeoPixel over here and LEDs, and the boot 0 button is actually also the pair button, because that way if you want to reprogram this board, you hold this down while powering it to enter bootloader mode. It's still got the regulator and capacitors, and probably uses a little bit more power. There's a battery on the back if you want to power the whole thing, but otherwise we made it pin compatible, and I loaded it up and it works great. So what's nice is that in addition to power and ground RX and TX here, we also have, you see, DTR and DSR. So there are two control flow signals. And even, a lot of times people don't use hardware flow control, but instead those are used for auto reset. So the ESP32 and Arduino Uno are in particular use those signals to kick the board into bootloader reset mode in order to upload code. That's kind of traditionally how the Arduino works, is the DTR pin is connected through a capacitor to reset. When it toggles, it passes that current through the capacitor, the AC current through the capacitor, reset line toggles and kicks it into bootloader mode, thus the auto reset, which I thought was essential, because that's, if you want to reprogram or communicate wirelessly to an Arduino Uno, you really want to have those control lines. So let me put this back. Hold on, this got loose. I'm gonna get the wires lined up. So red LED means it's ready to connect. SPP Bluetooth, basically when you open the port, it turns blue. And I can actually I wasn't going to do it, but I can over here on my computer. I opened the COM port, and now it turns blue. And when I close the COM port, it turns red again. So basically, what's interesting about SPP is, again, different than Bluetooth Low Energy, is on a computer it looks like a serial port. So let's go to the computer and I can show that off. So what happens is that on Windows particular, and we tested this, the flow control doesn't work on Mac, but it does show up as a COM port, serial port on Mac, Windows, and Linux. There's actually some bug in Mac OS, and unsurprisingly, it's so rare for people to use Bluetooth SPP with flow control, even though it's in the spec. Almost nobody uses it. We're using something that's technically there, but again, Mac OS doesn't support it, but Windows does. And it shows up as a paired device. It looks like a phone because it's what do I know? And then it actually creates. Let's look at the device manager. 2 serial port over Bluetooth links. Now, I don't know why there's 2, but basically you only use the second one. The first one doesn't actually exist. I don't know what it is, some weird placeholder. But again, SPP is like super freaking weird. It was used by Nokia phones like in like the mid 90s, and kind of hasn't been used yet. It's used since. That said, it's always built into operating systems. So then, if you have your, this is like a NeoPixel demo, and I select that COM port 31, and let's try this out. I'll try uploading. Because we're passing through that serial control line, it should auto reset the Arduino and perform the upload pattern. And if you have RTS and DTR, you can upload to an ESP32. It uses 2 control lines. The only thing is, because I opened and closed that port, it might be a little upset. I don't know. Is everything wired up? Maybe I'll do a hard reset here. Okay, and meanwhile I can show another demo. I'm still working on the Bluetooth stuff. So on the other side, we've got the Pico W, which we've been doing work on. Jepler's been slowly but surely adding support for the Broadcom, God, what is it, like the CS4343? I don't remember the part number that provides the wireless and Bluetooth on the Pico W. And there's a MicroPython driver and there's a Pico SDK driver, which is used in Arduino, but we wanted to add it to CircuitPython because we've got Bluetooth and, we got IoT and Wi-Fi drivers and Adafruit IO. We wanted to get this working. So far the status is we can, get the MAC address from the Wi-Fi, and we can scan for networks. So there's a lot of repeats in the networks, and I think that's normal. I don't think I can zoom in. There's a couple of repeats, so you'll see like the same ones show up multiple times. It doesn't do like a uniqueness filter. And then we can connect to Wi-Fi and get an IP address, which is done by like the underlying firmware. It's like we haven't actually touched the TCP/IP stack yet. Like just getting an IP address, like it's, even though IP is part of TCP/IP, we're not actually touching the stack quite yet. Meanwhile, let me quit Arduino and restart. So that's good news. So the next steps for this is to add LWIP, which is the, again, TCP/IP stack that's used. This is different than, using Airlift with the ESP32, where like the TLS, the SSL stuff and the TCP/IP stuff is all kind of managed on that chip. The 4343, the Wi-Fi module, like it really only provides like the underlying like the lowest level of communication. And for stuff like security, you have to add on top of that. The thing that's going to be a little interesting is all that is going to take up a lot of RAM and flash. It's going to be interesting to see how much is left, especially on the Pico W, which only has 2 megabytes of flash. We're probably going to have to shrink the file system in order to make room for the TLS stack in particular. Okay, so let me close that. All right, so the next thing is, speaking of flow control, it's been a flow control weekend. I wanted to see if this works this time. Oh yeah, now it's working. I think I just have to restart Arduino. Okay, so let's go to the, do you mind going to the overhead? So I'm going to open up this NeoPixel example and I'm going to upload it. And then I'll show you you can see, we'll see the activity LEDs as well. Just give it a second to upload. Okay, so it connected and now it's communicating. That's the RxTX LED, and then it uploaded the NeoPixel sketch. So yeah, basically I opened the port and in Adam, I shouldn't have done that. Probably got a little bit confused, but it does work. It works pretty fast. So I want to do a little bit more testing, and I also want to update the module because I used a Pico O2 module here, which has 8 megabytes of flash and 2 megabytes of PSRAM, which is kind of overkill. Like, it's what I had handy because I've been using it in the Feather V2. But as I'll show in the Great Search, it's a little bit more expensive, and I want to say, I want to basically make this as inexpensive as possible. If I don't use the PS RAM because I don't need it, I'm not going to use it. Okay, so kicking back, pop in the stack. The the CP2104N, I've been replacing this with the CH9102F. From WCH. It's using the old PCB, but it's actually the WCH chip. And what I've been designing the tester for this, like the board worked, and I was like, yay! And then when I designed the tester, part of the test procedure is I connect the flow control lines across of each other, and I use that to verify that they toggle, because it's a good way to just, I test RX and TX against each other. And then I want to test I test DTR connected to CTS and RTS connected to DSR, and basically like I connect them and I toggle the pins and make sure that they are connected back and forth. But I was actually having a lot of problem with CTS. The CTS line wasn't reading. Every other pin was reading except for CTS, but I knew it was working because I would test it on my Windows machine and it was working. It turns out that the Linux driver for that family of USB serial chips has a bug in it, and the CTS line doesn't work. So this is kind of more like an FYI if anyone there is replacing their chips with the CH9102F, and you're like, why isn't my flow control working? Why isn't CTS working? It's a Linux kernel bug. So let's go to the computer and I'll show you how to fix it real fast. These are just my notes. You will have to compile an out of tree driver, but not a big deal. Just apt-get install the kernel headers here, and that's you'll have to do it for each Linux kernel update. If you update the kernel, of course, you'll have to redo this. And then this person who works for WCH, I'm almost positive because they wrote a bunch of other drivers. They have a new driver that they updated 3 months ago, and this is a fork of the official driver. They did a PR, but didn't get pulled, blah, blah, blah. But you upload this, and this, you can insmod the CH343, which is that whole family of USB serial chips, and CTS will work. You have to remove the old CDC ACM module, by the way, so don't forget to do that. So unload the CDC ACM, mod probe the CH343, and it comes up as a new name, and CTS works. Again, a lot of people don't use that CTS line, like flow control isn't that popular, but I know somebody out there is like using, they want to use this chip or this family of chips, and just FYI, if you're having that issue, it's not you and it's not your hardware. So check out this repo and compile the out of tree kernel module. And ideally this would get put back in the main line, but WCH doesn't seem to be interested in doing that. So that's that. All right, so that's my whirlwind tour of what's on my desk. So any questions before we go into
let's hit the Great Search.
the Great Search? Let's do it.
Where in the world is that part I need? The Great Search with DigiKey.
The Great Search brought to you by DigiKey and Adafruit. Thank you, DigiKey. Every single week, Ladyada uses her powers of engineering to help you find the things you need. Ladyada, what are you looking for on digikey.com this week?
Okay, I'm actually doing a twofer because I have two modules that I want to swap around that use the ESP32. So one of them went in a line. So let's go to that first. Let's go to the computer and I'll talk about this module. So we use the ESP32 for a bunch of things, including this airlift technique, which Arduino came up with originally, where you load firmware onto the ESP32 and then it becomes an SPI client, and then you can use that as a Wi-Fi chipset. Really great when you have something like, RP2040 or an Atmega chip, something you want, or, an R52. You want to add Wi-Fi as a coprocessor, you'd use something like this. So the good news is that, historically, we've used the classic ESP room. It's this kind of chunky but very serviceable module from Espressif. It's very inexpensive. It uses the ESP 32, 4 megabytes of flash, no PS RAM, but it has a built-in antenna, and it's it's solid, like it's like a beast, right? This isn't everything. So we have the shield and we have the feather wing. Although the feather wing is a little bit of a tight fit, it does work. And then for the Itsy Bitsy, we use this U-Blocks module, the U-Blocks Nina, which is again also used by Arduino on their like Nano Connect or Nano Wi-Fi boards. And what's nice is that it's extremely compact. Okay, but you know what I'm about to say. So the problem is that this module, I just got a notice like last week that it is under last time buy. This is the one I think I'm using. Yeah, so they still have a bunch in stock, but it's last time buy, which means I can put in one last order, but they're no longer going to be making this. So, thanks for the warning, and it is in stock, which is better than a lot of chips that we've dealt with in the last 2 years, where we'd get a last time buy, and they're like, but we don't know when we're going to get them to you. So, I'm going to pick up a couple just to kind of ease the transition, but I have to find a replacement for this, and I want it to fit on that Itsy Bitsy wing, which is very small. And then likewise, I've got the Easy Link. Oh, can we go to the overhead real fast? I'll show this again. I've got this Easy Link board, and when I put this together, I used the ESP32 Pico module, which is an ESP32 with 8 megabytes of flash, 2 megabytes of PS RAM, and it's extremely compact. But it's a little bit more expensive, and I'll show the pricing differences for all these. So I basically want to find, I'm like doing two things. One, I want to find what's the best module to replace that Itsy Bitsy wing with the Nina W10 series that's end of line. So a very compact module, maybe it's this one. And I also want to find a replacement for this module that maybe is a little bit less expensive because I don't need 8 megabytes of flash in the PS RAM. So 1 second, I'm going to just quickly open up something on my computer, and then we'll switch over.
All right. I'll ask a question.
Ask a question.
Will the ESP32 C3 support ESP SPI?
It doesn't yet. Sorry, I'm getting distracted. Hold on. Bluetooth. Easy Link. Okay. So now I'm going to open up both files so we can look at them. Okay. So let's go back to the computer. Top. Hold on. Let me open up the TW. Okay. So this is the ESP Easy Link. So the one thing is that I really want to keep the width of the board the same because I'm trying to match the original Easy Link, which was longer, but it had this nice width. I want to make it pin compatible because it's very easy to swap it out. And again, this module was let me see if we can open the V2. This is the version using the original. Hold on. Uh-oh. This is the original module using the CSR chipset. Let me turn on TW. So you can see it's extremely long, but extremely skinny. So it's like it did kind of just keep going. But it was many stories. But it's nice and compact. So I did like that when I did this transition. This is a little bit squatter, but it has that same footprint. And then likewise, I'm cheating because I'm showing the head, but this is the Itsy Bitsy wing, and you can see how skinny that Nina W is. I mean, it has to fit between these two. I think 0.6. Let's see. This is 5. Yeah, this is 0.6 inches apart. So it's the size of a large dip chip. So this one again don't need a lot of. For neither of them, we don't need a lot of PS RAM or flash. 2 or 4 megabytes is going to be okay. We don't need PS RAM. Of course, I'm always interested in going with the lowest cost part available. I do want a built-in antenna. I don't necessarily need a UFL antenna option, but sure, later if that's available. But basically, most people want a built-in antenna. And to do this, I actually recommend going with the ESP product selector. Now, DigiKey has all the parts in stock, but the ESP product selector is just a little bit more specialized, again, for those ESP modules. And I found this is a good way to kind of see the lay of the land. And then I go to, of course, you can't buy from Espressif directly. You go to the distributor, you go to DigiKey. So let's start now. Okay, so for what I want, so I definitely want Wi-Fi. I do not want, I want Bluetooth Classic for that one board, which means I have to use, for the EZ-Link, I have to use the ESP32. Again, for the Itsy Bitsy, I don't need Bluetooth. However, right now the Airlift code only works on the classic ESP32, so we're going to use only the classic ESP32. I can't use the 8266, no classic. Ditto for the S2, C3, S3, and C2. So that reduces the list down to 72 pieces. Next up, system on a chip or module. I want the module because I want it to be like the FCC stamped and everything tinned and ready to go. I want to just place it. So we're going to go with a module. Status, I want mass production. Core, I don't really care if it's single or dual core. Antenna, I do want it built in. I want it to be PCB antenna. IPEX is the pluggable antenna. Okay, so let's see what we've got here. Maybe I can't quite reduce that. This is unhideable, huh? That's okay. Okay, so we've got all these modules down here. And the thing that's most important to me is size. So I'm going to search by size and moving up. And then you can see there's a couple options with PSRAM and, all of them are going to have some different flash, different PSRAM. Another thing to note is they all slightly have different GPIO availability. So just keep in mind all the modules that are available for the ESP, like each time you change package, like there's 4 pins that swap in and out. So just be aware, like GPIO like 10 and 15, 10, 17, 18, 19, 20, those numbers tend to kind of flip around. Okay, so these are all in production, and let's look at the sizes. So the Pico is definitely the smallest. It's got a 13 millimeter by 16 millimeter size, whereas the Mini, remember there's the Pico Mini and there's the Mini. The Pico Mini is 16 millimeters, 17 millimeters tall. The Mini 1 is 19 millimeters tall. So for visualization, I started adding these here. So this is the U-Blocks, which is actually the smallest by far. You can see they're really good at making extremely compact designs. They put the pads on the bottom. They use like BGA parts. I don't know what the heck they did. I've never uncapped it, but it's extremely compact. This is the Pico, which is again 17 millimeters tall, and this is the Mini. Note that they're not, this is the same width, but it's taller. It actually has the same number of pins, basically. It's just like a little stretched out. So this one, the chip inside, the chip that's in it, the ESP32 Pico chip, has the PSRAM and flash all on one die. I think the Mini has, maybe the flash is separated or something. It's a little separated. And then this is the Waroom, which definitely has the flash and then a spot for memory separated. So this is kind of and this uses SOIC flash. So they tend to get less expensive as you get bigger because you don't have to have as tight integration. But of course, they're bigger. Although they all pretty much have the same RF performance within reason. So the thing about this is, this is the Itsy Bitsy wing. I'll turn off the bottom layer. And really nothing beats this U-Blocks Nano. I could fit the Pico. It would be a tight fit, but it would fit right there in the middle. And then this would fit too. It's the same width, but I have to really start squishing all the parts back. Maybe even go with a double-sided design. So this is a little bit tougher. we'll look at the price differences for these. So if I go to DigiKey and I look for ESP32, and then I want transceivers and modems, I only want the active ones, and I only want ones that are using the ESP32 chipset, not the S2, not the S3. There are a couple different variations of the ESP32. And I want it from Espressif. I'm going to use the Espressif modules because, again, U-blocks are discontinued. And I want it to be a module. I want antenna included, trace antenna. I don't want the IPEX or UFL. Okay, so, and then is there a way to get just the modules? I don't know if modules are. Well, this says module, but it's not really module. I'm going to stick with this. So if you search by price, if you sort by price, the mini module is kind of the least expensive. It's about $250 in quantity. And then there's a version that has the UFL antenna if you like. There's the H4 version. This is the same but a little bit earlier, so it's not recommended, I believe. It's kind of not end of line, but it's like slowly being discontinued. And then the Waroom is actually a little bit more expensive. So it turns out it's actually cheaper for me to go with the mini module. The Pico is all the way down here, is more expensive. It's $4 in quantity. And it's more expensive because it's got that PS RAM in it and it's got double the flash. All things being equal, you're always going to pay more for, well, you tend to pay more for more integration. In this case, it's interesting. It's actually less expensive. But you're definitely going to pay more for flash and PS RAM. Like those cost 50 cents no matter what. So it's not surprising that double it and your price basically goes up $1.50 per. But the mini module is actually kind of like, very affordable here. It's inexpensive. It's $250, and there's a version with and without the antenna. So, I think if I can, it might actually be worth it for $1.50 to move from this U-blocks to this module that's $2.50 and maybe even go double-sided. Going double-sided or like going to much smaller components is always a little bit of a risk, but if you can save $1.50 on your bill of material cost and your process only ends up being $1 more, it might be worth it. And then of course the Waroom will like totally not fit, so I have that choice. So when I do my sizing for modules, I like to pick out between them. And then likewise for the EZ-Link, let's see, I can show some sizing differences. So ESP32, and then I have these all in my library, all the mini sizes. So this is the Pico, and then the mini, which would just be a little taller. It wouldn't make the size any wider, and I'm okay with making the board a little taller as well. And then one side note is, in case you're curious, the ESP32C3 mini is actually the same size as the ESP32 Pico. So if you would like to, if it is possible to use the C3, I don't have it here. If you would like to use the C3 though, in the product selector you can, oh no, wrong product selector, sorry. In the product selector, the Pico Mini is 13 millimeters wide by 16 millimeters tall. If we change chipsets to be the C3 Mini is likewise 13 by 16. So the words Pico and Mini, just be aware they don't always mean exactly the same thing between chipsets. That was surprising to me when I saw that the C3 Mini is the same size as the ESP32 Pico. But again, I can't use the C3 at this time, so I'm going to go with the Mini 1 and 4. There's lots in stock. They're $250 a piece. They'll do the job well. It's actually a little cheaper than the Waroom module. It's got a built-in antenna, and it'll fit in both of the boards that I'm designing for.
That's a great search.
Where in the world is that part I need?
Okay, tune in this week for all of our shows and more.
Hydrating.
Show and Tell this week is hosted by Melissa. We'll be doing Ask an Engineer on Tuesday, JP's Product Pick of the Week on Wednesday, 3D Hangouts with Noah and Pedro, Thursday, JP's Workshop, Friday, Deep Dive with Tim. And with this, we went to Little Island. It's a park not too far from here. And I saw a friend of mine who happens to use LEDs. It was daytime, so you're not going to see LEDs in this particular demonstration.
Yeah.
But uses LEDs in this big wheel, and he does this wheel art where he's inside of a big wheel. But since it's daytime, you'll just see his form of art here. That's what we're playing out with. See y'all next week.
All right. See everybody.